Hi, everyone, and welcome to our discussion on equilibrium. So, in this discussion, we're going to first look at our translational equilibrium and what that is. But in order to do that, we need to do a little bit of review. So, this entire little mini unit, per se, it really should serve as a review of forces and of torque. Okay. And so we're going to first look at Newton's laws. When we look at Newton's laws, there are three main laws or three laws to Newton's laws. The law of inertia, an object will continue doing what it is doing unless it's acted on by an outside force. So an object in motion will stay in motion unless acted on by an outside force. An object at rest will remain at rest unless acted on by an outside force. So for example, if I have an object that is moving at constant velocity, it's going to stay at constant velocity. If I have an object that is not moving at all, it's going to continue to not moving at all unless I act on it with some kind of force. Okay, so the only way for an object to accelerate is if a force is acting on it. Newton's second law is looking at acceleration. Acceleration is directly proportional to force and inversely proportional to acceleration. So what this usually is written as is sum of forces equals mass times acceleration. Now, another way that I like to write that is I like to write our acceleration is equal to force divided by mass. And in this diagram right here, you can see, so when I have a bullet being shot from a gun, okay, and this is going to apply Newton's third law, which is every action force has an equal and opposite reaction force. So in this case, we have the bullet and the gun. Which received the larger force? Well, they both received the same force. That's Newton's third law. So this right here is Newton's third law. Okay. Now it's going to accelerate. And the reason it's going to accelerate, or there's going to be an acceleration, is because there's a force acting on it. So that's Newton's first law. Okay. And then Newton's second law is saying that our acceleration is going to be small if our force is small based on the mass of our gun. So as our mass increases, acceleration is going to decrease. Those are inversely proportional. Now, my acceleration of my bullet is going to be much greater because the mass of the bullet is so much smaller. See, your two forces are exactly the same. That's Newton's third law. And so your acceleration is equals force divided by mass. So again, as mass increases, acceleration decreases. As force increases, acceleration will increase. So when we're talking about translational equilibrium, we are talking about sum of forces equals mass times acceleration, but what ends up happening at equilibrium, sum of forces is equal to 0. Okay, an object is in translational equilibrium if it is moving in a straight line at constant speed or at rest, meaning that the sum of forces equals 0. So it's super important for you to know that translational equilibrium is when the sum of forces equals 0. That means our sum of forces in our x equals 0 and the sum of forces in our y is equal to 0. So this diagram right here is a very common diagram that we will see. Some things that you need to remember from our discussion on forces is how to draw a free body diagram. Your free body diagram has your force of tension going this way, and then you have another force of tension going this way. Remember, when you're drawing the free body diagram, the arrow, the vector, starts at your object at the center of mass, and then it goes out. The arrow goes out away from the center. And then you have a force of gravity, so our F sub G or our capital W. Okay, something else that's important for you to recognize is SOHCAHTOA. Remember SOHCAHTOA. So when I'm looking at my force in my y direction, I have a sine 39. Sine 39 is equal to my opposite, which is my force in my y, divided by my hypotenuse, which is 250. And you can see that written here. Okay, so this is my force in my y, and here is my force and my x. In this case, your force and your x is cosine. Now, remember something else that we talked about in this unit is that your cosine is not always x and your sine is not always y. It really depends on where those forces are and where those vectors are. So please make sure that you pay attention to that. So we're going to dive into a few practice problems here. The first one being a block is at rest on a frictionless horizontal countertop under the influence of 3 horizontal forces. Okay, the given diagram shows a top view of the box along with the 3 forces. Use the given information to find the magnitude. So this is like I'm looking down on a box. I'm like a bird looking down. This is my bird's eye view. So I have a force 1 this way. I have my force 2 this way. And I have my force of 100 that way. Okay. And so what we're going to do is we're going to look at our sum of forces here. Okay. And so our sum of forces in our X and our sum of forces in our Y are going to be important. So I'm going to split this sum of forces X equals 0 and my sum of forces Y equals 0. Okay. Why do I know my sum of forces equals 0? The key information here is that the block is at rest. Okay. And so now I want to look at what are my X forces and what are my Y forces. So when I'm looking at this, I'm going to set up my coordinate system this way. We have our positive X, positive Y, negative Y. Okay, so when we're looking at our sum of forces in our X, we know that the sum of forces in our X are going to be equal to 60 newtons because we are given that 60 newtons plus force 2 in the X direction minus 100. Okay. And then we know our sum of forces in our Y are equal to, we have our force 1 in our Y direction minus 42 newtons. Notice we only have these 2 forces in our Y direction. Okay, so we know that the force of Y for 1 is equal to 42 newtons because we know that this is equal to 0. Okay, and then in this case, we have 60 minus 100 is negative 40, so 0 equals negative 40 plus F2x. Okay, and that tells us that F2x is equal to 40 newtons. And it says you're finding the magnitudes of the 2 unknown forces. So to be able to do that, we have F1. So if we remind ourselves, we have F1 is right here, and we know F1 in our Y is 42 and 60. Okay, so if we look at that, a squared plus b squared equals c squared. We know that F1 is equal to the square root of 42 squared plus 60 squared. That's going to end up giving us a value of 73 newtons. Okay. And then F2, we're going to use the same method. Okay. We're going to use we have 42 squared plus 40 squared, and that's going to end up giving us 58 newtons. Now recognize it says find the magnitude, so we don't need to find the direction in that problem. Okay, so let's look at another question where I have a hanging object, and this is a very common question here, as shown in the picture. If the tension in the right cable is 250 newtons, find the tension in the other cable and the weight. So the first thing that we're going to do is we're going to draw the free body diagram. The free body diagram right here is going to be, there's going to be a tension that way, a tension this way, and then our weight or our force times gravity. And it says the tension in the right cable is 250 newtons. So this is going to be 250 newtons, and this is going to be tension left. Okay. So then what we're going to do is we're going to go ahead and split this problem into our X and our Y components. So when I look at that, I know because it is at rest, my sum of force in my X direction equals 0, and my sum of force in my Y direction equals 0. Okay, so my sum of forces in my X direction, those are going to be equal to 0, but those are also going to be equal to, we'll call this tension right X minus tension left X. Okay, and if we're looking at this in terms of this is our triangle, okay, and this is what our angle is, our X is going to be our cosine, and our Y is going to be our sine, okay, because our sine is our opposite. So here we know that's equal to 0, so we know tension right X equals tension left X. So we know tension, which is 250, cosine 52 is equal to tension left cosine 24. Okay, and that's going to end up giving us a value of tension 2, or tension left, is equal to 168 newtons. Now, when we're looking at our sum of forces in our Y, our sum of forces in our Y are equal to our tension right Y plus tension left Y minus our force of gravity, or our weight. Okay. Okay. So because that's equal, all of that is equal to 0, I know that our force of gravity is equal to tension right Y plus tension left Y. And so our force of gravity, or our weight, is equal to 250 sine 52 plus 168 sine 24. Okay, and I'm getting those angles from my problem right here. Okay, and so that's going to end up giving me that my force of gravity, or my weight of my object, is 265 newtons. Okay. Now, this next question is very similar, except for it says a 1,000 kilogram object is supported by cables as shown in the picture. Find the tension in each cable. So here I'm given my mass, okay? So this right here is my mass times gravity. Then I have my tension 1, we'll call that, and tension 2, we'll call this. Now notice that my free body diagram, I'm starting at the center of my object, and I'm a little off center, but I'm starting in the center and I'm going away from the center with my vector. Okay, and so my arrow, the tip of my arrow is going to be right over here, the head of my arrow. Okay, now in this question, what I'm going to do is I'm still going to split my X, Y, and it says it's supported in the picture. So it's hanging there at rest. So I know that my sum of forces in my X equals 0, and I know that the sum of forces in my Y equals 0. Okay. So I know that my sum of forces in my X is equal to tension 1X minus tension 2X, just like it was in the last problem. And so because those are equal to 0, I know that the tension 1X is equal to tension 2X. And again, just like the last problem, if I'm looking at my right triangle here, okay, my X is my cosine and my Y is my sine. Okay, so I know tension 1 cosine 53 is equal to tension 2 cosine 28. So then I can look at that and say, okay, tension 1 equals tension 2 cosine 28 divided by cosine 53. And I'm going to use this in substitution in my next problem. So now I want to set up my problem sum of forces in my y. Well, my sum of forces in my y are tension 1y plus tension 2y minus my mass times gravity. Okay, so I know that 0 is equal to tension 1 sine 53 plus tension 2 sine 28 minus my mass times gravity, and that's 100 kilograms. 100 kilograms times, I'm actually just going to round that to 10, round my gravity to 10. Okay, and so then I end up getting that 1,000 is equal to T2 cosine 28 over cosine 53. Now you might be going, well, where the heck did you get that? I used this problem over here on my left, and I substituted this right here for my T1. Okay, and then times sine 53 plus T2 sine 28. And hopefully you realize my sine cosine is going to be tangent 53. So I end up getting 1,000 equals T2 cosine 28 tan 53 plus T2 sine 28. And that ends up giving me T2 is 609 newtons. Okay, and then I'm going to use substitution to solve for T1. So T1 is equal to 609 times cosine 28 divided by cosine 53. And that's going to end up giving me a value of 893 newtons for tension 1. Okay. So that's it for our translational equilibrium problems. Our next video is going to be on static equilibrium. So static equilibrium is when we're going to combine our sum of forces in the x and the y direction, and then our sum of torque, so our rotational forces.